Quantum mechanical model. Now let's look at our prior knowledge. Okay, first of all, you have learned about how to write certain electronic configuration. Now this time we use the electronic configuration of SPDF notation. Okay, then this one which has closest one, okay, is actually orbital diagram. Okay. Now let's look at this. 1 represents the number of shells or number of orbits or principal quantum number. S stands for shape of an orbital, sphere, and then the arrow here represents electron. Okay. Now next one, let us look at the 4 quantum number NL, MS. Okay, the first one is number of shell, principal quantum number. Okay, the second one represent shape, okay, dumbbell shape. So if it's dumbbell shape, it is P. So the number given is to represent is 1. Okay, electron in P orbital on specific axis. Okay, another one, the last one will be the electron spin. The positive or negative represents the direction. Okay, now let's look at this. Principal quantum number, highest. So you can look for the electronic configuration to determine the highest principal quantum number. Okay, for drawing shapes, I would like to highlight for 2s and 4s, what is the difference? Okay, 2s means there are only 2 shells. 4s, 4 shells. Therefore, 2s is smaller than 4s. When you draw, you must show the difference. Okay, now next one is I choose 3dxy and 3x squared dash y squared. Okay, these two are different although they look the same. Okay, and then another one is how to label 3dx squared and y squared. Later I will show you again how to draw 3D shape. Okay, when this type of question asks which orbital are allowed or not allowed, you have to remember all the rules. Okay, for example, 2f. When n equals to 2, L is n equals minus 1, it must be 0 or 1. But f is 3, represents 3. Thus, 2f is not allowed. Okay, another one. They are asking for possible magnetic quantum number. Magnetic quantum number depends on L. Okay, so if it depends on L, we must know, okay, 2p here means that we know it is 2. Principal quantum number is 2. P is represented by 1. So when L equals to 1, M equals to 0, negative 1, positive 1. Okay, so this is the answer. Now this time we are going to write the 4 quantum number. Okay, this one it says that only an electron. So when an electron, how do you write it? Okay, first of all, let's look at 2s first. Okay, so we know principal quantum number is 2. S is represented by 0. And then the rules given is when L equals to 0, M must be equals to 0. Okay, and then you can choose either positive spin, clockwise spin, or anti-clockwise spin. You can give a pair and label all, or you just give either one. Okay. Don't use comma. Comma means and. Okay, so this is the same. All this depends on the rules. N, L, M, S. Always look at the N first, and then L is related to M. Okay, for spin, we cannot use positive and negative together. For maximum electron, okay, if you are only talking about n equals to 3, n equals to 2, then you can use this formula. If you want to know for each orbital, you can draw and then you can find out the answer. Remember, one orbital maximum is only 2 electrons. Now let's look at how to draw. Okay, for example, I choose 3D exact. Okay, first of all, label 3D exact. Okay, then the axis X, Y, Z, draw first, and then if you want X, okay, then you draw two parallel line to X-axis. Then another one is Z, so you draw another two parallel line to Z-axis. And then you start to draw the lobes. After that, you shade them. Okay, that's all. Okay, if the question only asks, draw any two shapes of the 3D orbital, then you can always choose 3D z square and 3D x square y square because they are the easiest to draw. If x square y square, it overlaps exactly on the axis, lies exactly on the axis, and 3D z square is the one that we say that is like donut, and then only one dumbbell and one donut. So these two are the easiest if they ask you to draw. Okay, so that's all for this part.